Alright, everybody, welcome to the Math Hive, where it is my goal and passion to teach you a range of topics in the field of math. Today we're going to be practicing with the circle equation for our SAT questions. I'm going to quickly go over each component of this equation, but if you want to learn more about how this equation was created, you should go and check out my last video where I go fully over how this formula was derived, what each component means. But we're going to take a look at these really quickly before we get into our questions. So this first component here is our x component, which creates our x coordinates of our circle. And then this is the y component. And what each of these is saying is we're going to form a circle based off of our center, which has an x coordinate of h and a y coordinate of k, and the radius of our circle is going to be whatever this r value is, r squared. So this equation here that I've just written is going to create a circle centered around 4 and 3. This is going to be the center of our circle. And the radius of the circle is going to be 5 because the square root of 25 is 5. So now that we've reviewed these, we are going to move into the questions. Alright, so I have picked out a practice problem that we are going to look at. Which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoint 4/3, 5? So the best thing to do here is look for those key pieces of information that can help us answer the question. So we know in our formula for our equation, which is what they're looking for, we know it has a center. And they gave us that center, it's 0, 4. So our equation is going to start with x minus 0 squared, which I can actually turn into just x squared, plus y minus this 4 here squared, which is equal to some radius squared, but we don't know that radius yet. But what I can already do is eliminate option B because it has this y plus 4 squared here. And I can go ahead and eliminate option D as well. Now at this point we just got to pick whether it's A or whether it's C. And to do that we need to figure out whether it's this radius squared or it's this radius squared. So let's think about doing that. So what I've done is I've drawn this circle and then I've added the 2 points because we know it has a center of 0, 4 and we know it has an endpoint 4/3, 5, and we want to figure out this radius. So how do we figure that out? Now if you watched my last video, you know that the way this works is we use Pythagorean's theorem. And that's how they came up with the radius, that's how they came up with the formula. So we know that this x length is the difference between these two x's, which is 4/3, and we know that this y length right here is the difference between these two y's, which is just 1. And now we know that 4/3 squared plus 1 squared should equal our radius squared according to Pythagorean's theorem, which is what we're looking for. And even if you didn't think about it this way, all you had to do was plug in this endpoint into the equation and you would have gotten the same thing I just got here, and then you would have been able to figure out what radius squared is equal to. So when we do the math for this, we get that 16/9 plus 1 is equal to 16/9 plus 9/9, which is equal to 25/9. That is our radius squared. Note, this is not our radius. Our radius would be the square root of this, but our equation doesn't use radius, it uses radius squared, which is why A is the answer. If you take a look at C, they given you 5/3. Some people might think that the equation is equal to radius and not radius squared, so then they take the square root of this number and get 5/3, and then they pick C. But remember, this follows Pythagorean's theorem, and it should equal C squared, which is in our case radius squared, which is why the answer is A. So I have a new problem here, and I think it's a little bit different than some of the other ones we've seen, because they give you the radius, but they don't give you the center. They tell you it just passes through a point, which is actually very key to this. So once again, we're trying to find an equation, and we're given some key components that has a radius of 10, and though they don't explicitly give us numbers, we know it passes through the origin, which is 0, 0. So we need to figure out the equation of a circle such that at one of these points, we don't actually know which yet, but one of these points on the circle is 0, 0. So first things first, we know it's equal to it's going to have a radius of 10 from the center, which means that whatever our values are, we don't know these yet. It should equal radius squared, which is 100, because that's 10 squared. So we can go ahead and eliminate option A. Now, if we're thinking about it, we know that the circle passes through 0, 0. So our x and our y value, if we plug in 0 and 0, it should work. That's what that means. 0, 0 is a point on the graph. So the best thing to do here is to go through each of these and test it and see if it actually does equal 100. So we're going to do that with B first. So 0 minus 5 squared plus 0 plus 5 squared. This is negative 5 squared, which is 25. This is 5 squared, which is 25. And that equals 50, not 100. So we know B is not the right equation. Now we're going to do the same thing with C over here. So 0 minus 10 is negative 10. Square that, it's 100. And this term over here means the exact same thing. That's also 100. And this is equal to 200, not 100. So we can eliminate option C. And by elimination, we know that our answer is D. Now, if we wanted, we could also test this as well. So this will be negative 5 root 2, and we have to square it. So I'm just going to show you a little bit how that works. We would do 5 squared times the square root of 2 squared, and these just ends up canceling. So it ends up being 25 times 2, which is 50. And this right here is the exact same thing as this, because when we square, we get rid of the negative anyway. So this is also 50. 50 plus 50 does equal 100. So we can confirm that D is the right answer, but just by elimination, we knew that it couldn't have been any of these other ones. And that's also a good time to mention that being able to do math quickly in your head instead of writing it out like this, like you automatically know 0 minus 5 squared is 25, so it can't be this one. 0 minus 10 squared is 100, it can't be this one. That can help you a lot. But also knowing the equation, because you had to have known that the equation was r squared, so it had to have equal 100, and then you could eliminate A. So this might be one of the tougher circle equation questions you could get, because you're going to have to do a lot of algebra with quadratics to actually get to the answer. So in the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? So they've given us a weird looking equation. It doesn't look like our usual equation. Let me write that over here really quickly. So at first glance, it doesn't look like our usual equation, and it seems very complicated, and it's like you don't even want to try and solve it. But we can, and you're going to see that this is actually just an expanded form. Think about it this way: if we expanded each of these quadratics here, right, because our x minus h squared, we could expand it out, our y minus k squared, we could expand it out, and then simplify it all. And then we would end up with something looking similar to this. They have it written out, they just don't have it in quadratics, in our squared form like this. So we're going to have to do a bit of algebra to get this equation right here to look like this equation right here. So the first thing I'm going to do is I'm going to try and sort of separate it so that we can look at like each of these independently, if you will. So first, I want to be able to turn these x parts into this thing right here. I want to be able to turn these y's into this component right here. And then eventually we'll be left with whatever this is, and we'll be able to take the square root of that to find the radius, which is ultimately what they're asking us. The other way to do this would be if they had possibly given us a point. We might have been able to try and figure out what the radius was, but they didn't give us the center. They didn't really give us anything. So we don't know anything yet. So this is the way we go about it. Now there might have been multiple methods that you guys have seen to turning these in from expanded form down to this form right here up top. But I think the best thing to do is first get rid of these coefficients in front of the squared numbers. It makes it just that more complicated. So we're going to divide this whole equation by 2. So what I've done is I've divided every term by 2, and now it makes it a little bit more easier to go from this to this. Now there's multiple ways you could go about it, but I think the best way is this method called completing the square, where essentially you're trying to figure out what that last term would be, such that you could turn this into a square that looks similar to x minus h. If this topic is a little bit confusing for you, I highly suggest you learn it, because if there's an equation like this is pretty much your only way. And there are going to be multiple occasions on different questions that you're going to have to know the completing the square method. At least that's going to be the quickest way. So in order to do that, we would take our b value, divide it by 2, and square it. So that'd be 1.5 squared, which is equal to 2.25, and that's what goes over here. And then same thing over here, we would take our b value, which is 1, half it, and then square it, which is equal to 0.5 squared, which equals 0.25, and that's what goes over here. But of course, whatever we add on this side, we got to add on this side as well. So I'm going to rewrite this like this. And then once you've added 22.5 plus 2.25 plus 0.25, you end up getting that this side is equal to 25. And now the whole point of the completing the square thing was that we can turn each of these into a square that looks like our x minus h squared and our y minus k squared. In this case, our h would be negative 1.5 because that's the number we got over here. But we don't even need to turn these into these just yet, because we already know that this ends up being our final radius squared. This ends up being everything that's left on this side. And if we want to find the radius, we just have to take the square root of 25, and we get that it's equal to 5. If we really wanted, we could complete the equation, once again using our completing the square method. Basically, you take this value over here that you ended up squaring, and that ends up being what you add over here. So this expression, these two terms are equivalent to all of this stuff up here. And now you can see it makes it nice and neat for us. And we know this is equal to 25. And now we know that 25 is r squared and r is equal to 5. So we've seen that there are tons of types of equations that they could give you, problems that they could give you just based on the circle equation alone. And there are different kinds of mix to it. There are different ways they could ask you to it. There's different pieces of information. But the best thing is to identify the information you have. Try and fill in that equation as much as possible when you know it's related to the circle equation. And then work your way around it. Maybe you're going to have to do some algebra. Maybe you're going to have to plug in values like our last one. Or maybe you're just going to have to form the equation itself and test out different things to find the radius. I hope you guys like this video. If you have any questions, feedback, or you want to see any other videos, please do let me know in the comments. Thank you for watching.